Space, the final frontier. And everywhere one very special element: hydrogen. Our sun supplies the energy that makes life on our planet possible. It too consists mainly of hydrogen. In the search for the energy carrier of the future, more and more of the world's scientists are pinning their hopes on this element. Produced in an eco-friendly manner, hydrogen could make a decisive contribution to solving our energy problems. The magic phrase is fuel cell, an unassuming name for an eco-friendly and very simple way of generating power efficiently. This is how it works. Hydrogen in red and oxygen in blue want at all costs to unite and become water. But there's an obstacle: a separating membrane. There is, however, one way for the hydrogen to penetrate the barrier. It divides itself up and gets rid of ballast in the form of electrons. The electrons then find their way to the other side via a wire. An electric current flows. As ingeniously simple as the principle is, for the scientists there are still substantial problems to be solved. It's a question of the fuel of the future, especially for mobile applications where hydrogen has been found to be the ideal energy carrier. One big problem in this context is storing the hydrogen, which is a gas and can at present only be stored under high pressure in tanks. We're developing alternative concepts based on hydrogen being bonded in the form of a chemical compound in a metal hydride. This is a challenge, a complex task which we can only solve in a Europe-wide cooperation with leading research institutes. Recent successes, however, show we're on the right track. So it's a question of finding substances light in weight, but that nevertheless bind as much hydrogen as possible. And the researchers found them. Metal hydrides, more precisely light alloy hydrides, possess the desired properties. And this is where top-level research is carried out. Here, velvet gloves are out of place. In a controlled atmosphere of argon, hermetically sealed, the researchers create the energy carriers of tomorrow. At an early stage, the scientists realized that above all, size is important. The finer the structure of the hydrides, the faster they can absorb the hydrogen. Micron-sized crystallites, on the right, store hydrogen with only moderate efficiency. Grind the hydrides much finer, nano-tiny, and things already look very different. This success was the first major breakthrough. And the mills in Geesthacht grind with that little extra bit of energy. In their search for still better storage substances, the scientists finally hit upon so-called borohydrides. Although already known to be good storers of hydrogen, as they only release the gas at very high temperatures, they were considered unsuitable. But the scientists succeeded in mastering the stubborn borohydrides. The new compounds store more than 11 weight% of hydrogen, a level never achieved before. And, best of all, a low supply of heat is enough to release the hydrogen and to be able to use it as a power source. And here the newly developed storage substances are put through their paces. After being inserted into the tank cartridge, they're filled with hydrogen under pressure. How much hydrogen will they absorb, and how quickly? The moment of truth. In Geesthacht, they're not only developing the ideal hydrogen storage facility for fuel cells, but the necessary polymers too. Polymers constitute a class of materials with wide applications potential. They can be used as lightweight construction materials, which is what we're working on here, but they can also be combined with magnesium as an anti-corrosion coating. We can also use polymers in the field of material separation. We develop membranes for low-energy material separation in the chemical industry, but also for use in fuel cells. Producing the membranes looks astonishingly simple, and yet behind it is the high-tech recipe for the ideal polymer mixture that was developed in innumerable tests. The GKSS Research Centre has evolved over time. In the last few years, it's become an institution in which urgent, contemporary problems of science, society and the economy are researched. And I'm certain that this development will continue with an even greater intensity in the future. The Helmholtz researchers from Geesthacht are in no doubt. They'll find it, the technology for the mobile energy of the future.